Okay, so Chapter 10, Mobile Devices and Client-Side Virtualization. This is actually the last chapter in our textbook. Okay, so let's start off with mobile devices. Our big thing here is we're going to look at what a mobile device is, try to define it, look at the hardware and software components that make up mobile devices. That includes tablets and laptops. Talk about how we can configure, secure, synchronize, and troubleshoot these devices. And learn about the basics of server-side and client-side virtualization. So operating systems used on mobile devices. We have 4-ish major groups now. I would not trust any of the market shares on this PowerPoint. This is all old and out of date, so keep that in mind. The 4 big ones are going to be Apple, Android, Windows, BlackBerry. They're the main groups. Apple would be Apple's iOS, Android, all the different flavors there, Android, Windows phones, all the different versions of Windows phones, and then BlackBerry is going to be BlackBerry specific Blackberries. Android OS is by mainly the Open Handset Alliance. They're backed by Google. It's a Linux based and have some really funny names like gingerbread, honeycomb, ice cream sandwich. This shows the age of this PowerPoint. This is showing that the newest release is Jelly Bean, and that's not really true anymore. Android supports Windows, panes, 3D graphics, all the general things that we've come to expect from our mobile devices. In general, all mobile devices are pretty much the same. The OS, or the operating system that runs on the phone, is the difference. Here we have navigation buttons on a typical Android phone. Next, going in, oh, I went back, sorry, I'm going to go forward. Next is the Apple's iOS, normally associated with iPhones. One of the big differences that I've noticed with iPhones is actually the iTunes. And that is generally for things to be released on Apple's iOS. Oh wow, this is version 5.1. So this is 4 versions out of date. 9.1 just came out when I was recording this video. Anywho, Apple's iTunes actually does some verification of apps before they're released. And for the most part, they will not release apps that could do damage. That means damage to the phone or to the user, or that where just Apple's just doesn't deem it good enough. Android market is more open. They'll allow much more things that aren't validated, so way to keep that in mind. So developers for Apple iOS, it's a closed source, which means you have to have the appropriate software, or Xcode, which is available for, well, if you have a Mac. If you want to code in it or code applications, there's plenty of resources out there for it. Android apps, which are open source, you can pretty much get this anywhere, but again, there's no assurance of quality. So it's just kind of at your own risk. Smartphone is a cell phone that adds the capability for messaging, multimedia messaging, voice, data in the form of web browsing, email, gameplay. Could also do things like streaming, taking photos, streaming videos, or any other type of applications that you want. Smartphones are common today. That's where you have internet access from your phone. So if we look at things like a tablet or mobile phone versus a laptop, the big thing here, size. Laptop is way bigger, which is more cumbersome. Now with the days of like Dell's XPSs or Microsoft Surfaces or iPads, Our tablets are actually becoming more powerful than laptops, and they're smaller, so they're more convenient, so more and more people are starting to use them. Touch surfaces. Most things now have a touch surface. No longer need a keyboard and mouse. You can just do it with your fingers or a stylus, also known as touchscreens. With actually one of the newer Apple devices, depending on how hard you press, that now comes into play. Like anything else, any type of computer, whether it be smartphone, tablet, laptop, all is going to have storage. We have greater and greater storage capacity within our mobile phones now. Now we can record, hours. I want to say hundreds of hours of videos, but I mean it kind of just depends on how good or how the depth of quality you want. Like if you're trying to shoot a 4K video from your mobile phone, probably not going to happen just yet. You want to record a 1080p video from your phone? Yeah, I could see that. But if you're doing 1080p, you're not getting hundreds of hours. You may have to go to 720 or 480. So I mean, storage is there now. So other new advancements are the gyroscope, and that's the motion and position sensor in the device itself. That way you can use things like Apple's health data tracker or Fitbits or other types of tracking apps that will track your movement. Also helps with the screen orientation. Also very useful for games. GPS. GPS is now built into phones after 9/11. That way the phone's GPS can be remotely turned on, so if need be, you can always be located. Normally this is done only in cases of emergencies, but that's why we have it. So most of the settings required to support the iOS device we can find in the Systems app. That is pretty much general for anything. Whether you have an iPhone, an Android phone, a Windows phone, a BlackBerry, you're going to go to settings to find most of the items that you need. Most smartphones have Bluetooth, have wireless, have cellular, and they also have an airplane mode. That way it will turn off any sending and receiving capability of your device. Here's an example of a older iPhone that's on the AT&T network. You can disable the cellular data. You can disable roaming. You can set up hotspots. You can also turn on and off Wi-Fi depending on what you need. Alright, so the important thing is not so much the differences between the phones. The phones are pretty dang close. So you're going to have to figure out which one you like best. The big thing is, how do you configure email on your smartphone? And that's going to be a few different ways. You could download the app specific for your mail client, or you could use a web browser, or you could use the built-in mail client. So we're going to be looking at how to use the default mail client on an iPhone. For this, you need to know your username, your password, and your server settings. Most phones, again, regardless of manufacturer, have some type of syncing, updating backups to some type of cloud service. BlackBerries now have it, Windows phones now have it, iPhone is back up to iCloud, Android is back up to their cloud. Again, this is all pretty standard now. iCloud, the book heavily focuses on iPhone, so I do apologize for that. With iCloud, you get 5 gigabytes of storage free, and your phone will auto backup to iCloud. If you want to back up to, let's say, Microsoft's OneDrive, you could do that as well. You could download the OneDrive app and go from there. In the settings in your phone, you'd go down to iCloud and you'd tell it what to sync. You could also manage your backups from here as well. So how do we secure our phones? One of the big things is, with our phones, they now have all of our data. Our email, our calendar, our voicemail, our contacts, videos, and photos. But how do we protect it? We can protect it by, for iPhones, again, track my iPhone. You can also do remote wipes from iCloud. You could track your phone from iCloud. But before we even get that far, how about if we put a passcode or a fingerprint reader on our phone so it cannot be unlocked without the appropriate code? That's always an option. Ooh, this is so out of date. You can set between a 4 and 16-digit code. I just recently downloaded an application and I had to put in a 16-digit passcode that became very cumbersome. The nice thing is, after so many failed attempts for password cracking, you can have your phone set to auto erase your phone or auto wipe your phone. Again, we've already talked about the Find My device or Find My iPhone, or again, almost all phones nowadays have similar things. It's not always about iPhones. Common problems: touchscreens, buttons stop working, apps stop working, malware on your phone. Those are all big things. So how can we start troubleshooting these? Restart, reset, update, restore. Those are the big ones. Restart your phone. Try updating your phone. If all else fails, try to reset or restore your phone. So how do we configure syncing and security devices with our Android? Again, it's all going to be dependent on the ones that you have, but again, most of that's going to be accessed through our Systems app. And again, for this, it's all going to be unique. So per phone, you're going to have the same general settings: airplane mode, Wi-Fi, Bluetooth. You may have cellular data as well. You should have an accounts and syncing option, so that will be it's syncing. So instead of going to iCloud, it will go to wherever it's supposed to be syncing. Here are other ways to look at those settings in a non-tablet. Again, Wi-Fi, Bluetooth, airplane mode, pretty similar stuff. Configuring email, again, same thing. You can do it through an app or through the built-in mail client. You're going to need to know the username, the password, and server settings. Normally they want you to have a Gmail account just because Gmail is a lot easier to set up on Androids, but not required. What types of things can you do? You could sync all of this back to your Gmail account. So you can also set many different types of services and servers up. Like you can set up a LinkedIn, a Picasa, Dropbox, Facebook, YouTube, Skype. Again, similar apps for both phones. Again, Android offers pretty similar things just like iPhones. You can sync. Most Android devices manufacturers have an app to back up the data to a external SD card. If you don't want cloud backup, you could do the same thing through iPhone, through iCloud, or through iTunes on a computer. Updates, again, same thing for both. Securing, again, same thing for both. Passcodes, antivirus. You can set failed logon restrictions, like after X amount of time is to wipe the phone. By default, it's 5. 10 on iPhones, 5 on Androids. You can set pattern passcodes. Troubleshooting Android devices, again, reboot, update, reset, recover. Pretty similar things. That's our mobile devices in a nutshell. Whether it be an Android, an iPhone, BlackBerry, or Windows Phone, again, they're all pretty damn similar. So let's go and move on to virtualization. Okay, so there are two types of virtualization that we're going to deal with right now. And we're going to deal with mainly client-side virtualization. And that's where the virtualization happens on the client side versus on the server. On the server side, the server or the host machine will process it and then send it to you via probably some type of network connection. Versus the client side, It'll have to be hosted and served on your specific machine. So the server side, it's going to use all the server's resources for virtualization. Client side, it's going to use your specific computer for the resource utilization. So again, server-side virtualization will probably provide some type of virtual desktop for more than one machine. That means all of these virtual machines are on a physical server, but multiple machines are connecting to it to gain access to that virtual desktop, also known as a VDI. Advantages? Better investment. You can, instead of purchasing brand new PCs for everyone, you can have just beefier servers, and those servers run the VDI. Disadvantages? You have to have high-end resources, high-end server, better network, and you have to have some experienced IT staff. The user experience may be diminished. That's completely subjective. Alright, so clients used with server-side virtualization could be a computer where you just access a website, could be a tablet, could be a voice terminal, it could be a thin client, it could be many different things. The nice thing is the VDI should be accessible wherever you need it to be. So if you're across the country, as long as it's a web-based VDI, you should be able to log into the VDI and have it. I've done web-based VDIs using Citrix and VMware products, and I mean, they're great. I can be working on a Word document or working on an Excel sheet, and then leave, pick up exactly where I left off, wherever I need to, because when I log back into the web client, my virtual desktop pulls back up, and all my work is still there just where I left it. So server-side virtualization, normally this is going to be storage in the cloud or working in the cloud. And there's different types of clouds environments. The big three that we're going to look at is infrastructure as a service, which this provides servers and storage for its clients in the cloud. Platform as a service, this will provide servers and OSs, but customers install individual applications. And lastly, software as a service, and this is where you provide hardware, OS, and applications. Alright, so the last thing we need to talk about is client-side virtualization. We've done a lot of this in class with VMware Player and VMware Workstation. And again, this is where virtualization will take place on your specific PC. So you have to log into your operating system, and then you have to open up your virtualization software. So we have our host machine, our physical machine, and then inside of that physical machine, we could have guest operating systems. And so the guest operating system is going to be our virtual machine. VMware Player or Workstation is going to be our hypervisor, and that is just some type of virtual machine manager. So we have different types of hypervisors. Type 1 is bare box. I mean, that's where you don't have to load an operating system first to access the virtualization. Examples of that could be Zen Server for Citrix or ESXi for VMware. If we're talking type 2, we're talking some type of host operating system, then a hypervisor, then our virtual machines. Hardware requirements, pretty straightforward. You normally want a newer hard drive or newer hardware. Normally things that will support virtualization, you want the appropriate hard drive and resource requirements like better processors, more memory. Make sure that the BIOS is set up and having virtualization turned on. That's a big thing. Other hardware requirements could be, again, verify date, time, drivers, a keyboard, mouse. All of those should be up to date and current so that the hypervisor can best manage those devices between our physical machine or our host OS and all of our guests slash VMs. And again, double check time, make sure all of that's good. Also verify drivers, verify all of the connectivity. So lastly, how do we secure a virtual machine? A virtual machine is just like any other computer. You would secure it just like you would a physical machine. That's actually it for this chapter. I wanted to thank you guys and hope you guys have a great day. Bye.